Okay, today is October 22nd. Hey, hang on. November, December, January, February, March, April. I am exactly 47 and a half years old today. Happy half a birthday. Happy half a birthday. Thank you very much. So we have 4 questions here, all of them are which are from chapter 6.4 in our textbook on multiplying a mixed fraction by a mixed fraction. So the first question we have here, if you want to try these again because you don't know how to do them, just press pause, try the questions again, and press unpause and watch the solutions. The first question gives us this rectangle, which is already broken up into 4 parts. So really, the area of this rectangle, the area of the whole rectangle, ignoring the fact that there's parts, would be 1.5 units long multiplied by 1 1/5 units long. So if I find each of the individual parts of A, B, C, and D and add them together, that will be equivalent to or the same as 1.5 multiplied by 1 1/5. So if I break down A first, and I'll use my A red here, A is going to be 1 multiplied by 1 because its length is 1 and its width is 1. So therefore, the area of the first part is just 1. The area of B is 1/2 times 1, which I think most of us know that when you multiply by 1, you keep its original number. So 1/2 times 1 is a half. So far, nothing very complicated. C is still 1 by 1/5, or 1/5 times 1 for an area of 1/5. So far, nothing complicated at all. And the only thing that's really difficult remotely is the area of this little section D. And D, as far as length and width go, it's a half multiplied by a fifth. And of course, in the last section, we studied how to multiply a fraction by another fraction. And we multiply the numerators, we multiply the denominators, and we would get 1/10. So given the fact that 1 1/2 times 1 1/5 is really 4 parts, it's 1, it's a half, it's a fifth, and it's a tenth. If we take those 4 numbers and add them together, so 1 plus a half plus a fifth plus a tenth, that will be equal to the product of 1.5 times 1 1/5. So the whole numbers I'm going to bring down here, just keep that down there. I'm going to add these 3 parts here. Of course, adding requires you to have a common denominator, so I'm going to use 10. 1/10 will stay 1/10. 1/5 is equivalent to 2/10, and 1/2 is equivalent to 5/10. So now that I have my 3 fractions made into equivalent fractions with the same denominator, the rule is keep the denominator and add your numerators, giving me 8/10. So I now have 1, and the remainder of those fractions would be 8/10. That's my answer. But of course, you've been preached to express answers in lowest terms. In lowest terms, it'd be 1 1/5. So therefore, this is kind of important. I know it's a lot of work. Therefore, 1 1/2, 1.5 multiplied by 1 1/5 is equal to 1 4/5. All that work for that one boxed up answer, right? That's what we did it for. We did it to prove, using an area model, that 1 1/2 times 1 1/5 would be equal to 1 4/5. But of course, what did we learn last day? We learned that there's a much easier way to do that. You can simply take 1.5 and change it to improper. You can take 1 1/5 and change it to improper. You can multiply the numerators to get 18, multiply the denominators to get 10. I get the exact same answer, but a lot less work. Your second question is actually one you hadn't seen before, but I gave it to you anyway. It's actually 1 3/5 multiplied by 2. That's what the question is really asking us. If I double 1 3/5. I'll just do the work inside the box here. So 1 by 2, this area of A would be 1 times 2, which is 2. This B would be 3/5 times 2. Now remember, in section 6.1, we learned how to multiply fractions by whole numbers by saying if I have 3/5 and I double it, I would have 6/5, which is 1 1/5. 1 1/5. Or since we now know that you can multiply fractions by the numerators, we can multiply the numerators as 3 times 2. And really, whole numbers have denominators of 1. So we can do it that way as well. All right. Then we would simply take a plus b, so 2 plus 1 1/5. And our answer is a very simple 3 1/5. Therefore, 1 3/5 multiplied by 2 is equal to 3 1/5. Now, of course, I could do the same thing that I did in the last question. Take my mixed fraction, convert it to improper, which would be 8/5, and multiply it by 2. But instead of thinking of 2 as being a whole number, I could think of it as being a fraction over 1. 2 and 2 over 1 are the same thing. Multiply your numerators to get 16. Multiply your denominators to get 5. How many 5s in 16? There's 3. How many left over? Same answer. Much more concise. Your next two questions simply say convert these to improper and solve. So 2.5 is really 5 halves multiplied by 5 halves. Multiply your numerators, multiply your denominators, and you will get 25 over 4 as your answer. That is the correct answer, but it's an improper fraction. You're encouraged to convert improper fractions back to mixed. That would be 6, which would be 24 quarters, plus an additional quarter. 6 1/4. And your last question, convert to improper and solve. So remember, if you're converting it to improper, the easiest way to do it is simply take your denominator, multiply it by your whole number to get 9, and add your 2 to get 11. Multiply 4 by 2 to get 8, add your 3 to get 11 over 4. So there's your question, 11 over 3 multiplied by 11 over 4. You can't reduce, you can't cross reduce, so you're just going to have to multiply it out. 11 times 11 is 121. 3 times 4 is 12. How many 12s in 121? Exactly 10. That's 120. And there's 1 left over. So your answer is 10 1/12.